Hello everybody. We have a GRE physics problem here to solve. In this problem, a block of mass m slides down an inclined plane with a constant speed. In this problem, we have to consider only part of the journey when the block slides down from a height h to the bottom of the plane. The coefficient of kinetic friction between the block and the plane is given to be mu, and it is asked to find out the energy dissipated against the frictional force during this segment of the journey. And your answer should match one of these five answers here: A, B, C, D, and E. Now, guys, you can solve this problem just in seconds in your mind if you apply the law of conservation of energy to this problem. It is evident that as the block slides down, it loses potential energy, and this potential energy is converted into the work done against the frictional force partly, and partly it is usually spent in increasing the kinetic energy of the block. Now, since there is no change in the velocity of the block, so there is no change in the kinetic energy of the block, and whatever change in potential energy of the block occurs there, that is totally converted into the work done against the frictional force. And what is this change in potential energy or loss in potential energy during this journey? It is mgh, and this energy is totally converted into the work done against the frictional force. So the correct answer is mgh here. B is the right answer. So guys, you saw that applying law of conservation of energy to such a problem is a very handy way of solution, and I would recommend to the students appearing in the GRE exam this way to solve such a problem in order to save time. However, such a problem can also be solved by considering equations containing the forces responsible for the motion of the block here, which is a bit lengthier process, but for completeness, let me go through that method also. Now, I have redrawn the given figure here, which now contains the details of the forces involved in the motion of the block. Uh, Two apparent forces are the weight mg of the block here. It is, this one is mg downward, and the other is the frictional force against the motion of the block. Call it Fk. This one. This is Fk. Now, since the block is moving with a constant velocity down the ramp, it means that the frictional force is balanced by some opposing force, which causes the block to move with a constant velocity. That is, there is no acceleration along the journey. And what is that force? It is actually one of the rectangular components of mg, this one. And this is mg sine of this angle, which is, by the way, also angle theta. A little thought will show you that this angle is the same as this angle, sine of theta. And this component of the force, you call it mg cosine theta. And since this acts on the ramp perpendicularly, there is a reaction force, the normal force, you call it the normal force, this one, which has the same magnitude as mg cosine theta. Now, let me write the equations here involved. Since the block is moving with a constant velocity, it means that Fk has a magnitude equal to mg sine theta that is this one. Okay, So call this one as equation number 1. And the frictional force is the also equal to mu, coefficient of kinetic friction, times the normal force, which has magnitude equal to mg cosine theta. So this is equal to mu times mg cosine theta. Call it equation number 2. Now, if I call this the journey distance as d, and the height of the triangle, the big triangle here, this is h as given in the problem. So h by d is equal to sine theta. Okay, now these are the basic equations here. Actually, they are involved in the motion of the block. So call this as equation number 3. So f of k here is in equation number 1 given by mg sine theta, and here in equation number 2 it is given by mu times mg cosine theta. So one thing we should write mg sine theta is equal to mu times mg cosine theta from 1 and 2. So from here you can see that mg cancels out, and from here mu is equal to sine theta by cosine theta, which is equal to tangent theta. Now, how about the work done against the frictional force? I'm interested in the magnitude of the work done. Actually, the work is negative because it goes to the environment as heat energy. So it is negative, in fact. But the magnitude of the work is, I write it like this, Fk times the distance d. Now this Fk is equal to mg sine theta from equation number 1 times d. Now from equation number 3, sine theta is equal to h by d. This was the purpose for writing equation number 3. So mg times h by d times d. Now d and d cancels out. So this is equal to mgh, which is the same answer as coming from the energy consideration. Okay. Now, one might be wondering that where has mu gone? Why it is not appearing in the answer if it is given in the problem? So it is absorbed somehow on the way. Let's consider another way of deriving the same result. Work done from equation number 2 can be written as like this. Work done is equal to Fk times d, and now Fk is from equation number 2 mu times mg mg cosine theta, I'm sorry, mg cosine theta times d. Now from this equation, call this one as equation number 4, say. From equation number 4, mu is equal to sine theta divided by cosine theta. So write it down here, mu times mg uh, uh, mu is equal to sine theta by cosine theta. Sine theta divided by cosine theta times mg cosine theta times d. Now this cosine theta cancels with this cosine theta here, and sine theta is from equation number 3 equal to h by d. So write down it here, h by d instead of sine theta times mg times d. So d and d cancels out, and you again get the same answer, mgh. So mu does not appear in the answer, and the correct answer is mgh again. So we solved it by three ways. Whatever way you follow, you will get the same answer. And I would recommend the energy conservation law is the best one here for someone appearing in a GRE exam in order to save time. Thanks for watching.